Hi there everyone, today we're going to have a look at enlargements once again, but this time rather from a point which you can see there on the screen is highlighted in red. Now we have this bluish, like a teal coloured triangle, and then we have this orange one. Now if we count the big squares or the smaller squares, you should agree that so for example, this is 5 squares, let's count 5, and this one is 10. So this is 3, and you can see this is 6 here. So I'm pretty sure if you've watched the last video, you're really happy saying this has been enlarged by a scale factor 2. Okay, but what happens when we enlarge it from a point is very different. So I'm just going to get rid of all that ink quickly. So what I've created here is this little dot. So when I move it closer, you can see we can't just draw it anywhere we want to on the page. So I'm just having a little move of this and start thinking as I'm doing it what is actually happening. So as I move the point closer to this blue one, what is happening? This is quite a good one to look at. I can move it diagonally away as well. So hopefully you can see that the scale factor 2, the size isn't changing. Okay, it is twice the size, that all the lengths have been multiplied by 2. But as I move it away from the blue shape like this, the enlargement is moving further away. It's kind of like a shadow. If the enlargement is the light source and this is the object, the shadow is the orange. Now if you're staying quite close to the light source, the shadow is very close to you. And if you're standing far away from the light source, the shadow is also further away. Okay? And it doesn't matter where we move it, even if we come over to the other side, the same thing happens. So as I go further away, the object does. And if I go actually on the point, so is the object. And this one's quite nice, I'll try and get it in the middle. Okay? So it's just worth noting what is actually happening when we enlarge from a point. Okay, so we can't just draw it twice as big or 3 times as big, whatever the scale factor is, anywhere random. It has to be an exact point. And if you think of the torch example that I just talked about, that should really help things. Okay, now for this one, the scale factor 2, if we bring it to here, say, this is 7 squares away, and you'll see this is actually 14 squares. So it's a scale factor 2, and that distance is also twice as far away. If I bring it to here, we've got 5 squares to the closest point on the blue one, and to that same point on the orange is 10 squares. So again, you can see it's twice as far. If I bring it to here, we've got 15 squares to get to this point. And we've got, another 15, so it's 30 squares to get to here. So again, scale factor 2, not just the sides are increasing by double, but also the distance away from the shape. So let's have a go at doing some of these ourselves. So here I've got a purple rectangle, and I've got this center of enlargement. Okay, and what we're going to do, we're going to enlarge this by a scale factor 2 as well. So I can see that this is 3 and this is 2. So I know it's going to be 6 up and down and 4 left and right. I know. But I can't just draw it anywhere anymore. So what I've got to look at is the distance. So I'm going to choose the closest point, which is that one. And I'm going to count the squares. 1, 2, 3, 4. So scale factor 2 means it's going to be twice that journey. So I can go 4 and then another 4. Or I could have gone, if that's 4, that's now 8. So from this point, what I'm going to actually do is draw a line, not 3 up. Okay, this line is now going to be twice the size from here. So we've got to this point here. Now, then we would go across 2. So now we're going to be going across 4. We then come. It's not playing ball. There we go. Then we come down another 4. And we would then come across 2. sorry, across 4. Right, so I was mumbling a bit there because I was having problems with my pen. But I think I said down 4, but it's down 6 and across 4. So that red rectangle is twice the size of the purple one and twice as far away. So that's it. So do what you did before, but now we're counting the distance as well and making sure that is also scale factor 2. Let's have a look at loads of questions. That's what you've got to do for these. Have loads of questions, loads of practice, and then it's just counting squares. So this one's a little bit harder because it's diagonally from it. So we can see here, that is the closest point. And that journey is 1 right and 1 up. So 1 right and 1 up. Well, for a scale factor 2, that's now going to be 2 right and 2 up from this same point. Or you're going to just do that journey twice. So you can go 1, 1, 1, 1. So that journey twice. Or you can enlarge it by a scale factor 2, the journey, and just go 2, 2. Either way, you end up there. Then from this one, it goes 1 up. We're now going up 2 because it's a scale factor 2. Instead of going across 3, we're now going to go across 6. And down 1 is now going to become down 2. And I just join these up. Like so. It's a bit of a dodgy one, but it's there. This one is a little bit easier because it's in line. When it's diagonally across, it's always a teeny bit harder. This is a scale factor 3, so this is a good one to see. So there's the closest point, and the journey is just 1 square up. So scale factor 3, that journey is now going to be 3 squares up, 3 times the distance. If that's a 1, that's now a 3. So we just have to draw it 3 times the size. So instead of going 2 right from this point, we're now going to go 6 right. Now we're here. Instead of going up 2, we're now going to go up 6 right to the top, and it's finished. You'll notice that I avoided the diagonal. Diagonals are always trickier, so I'll always go for horizontal and vertical if they're there. If there's no diagonals, we'll deal with that as well. So, oops. Okay, there it is. So, really important, when you're enlarging from a point, it's not just the size we enlarge, it's also the distance to or from, or even the distance travelled from the centre of enlargement. Okay, so enlarge this one by a scale factor 2, but this time they're just telling us where the centre of enlargement is on a graph rather than us being given it from the start. So 4 minus 3 along the corridor, this is x, this is y. So x is across, y is up or down. Okay, so I'm going to go to this point because it's purely the closest, and I'm going to say that is 1 left and 2 up. So 1 left and 2 up. Scale factor 2, so I'm going to do that journey twice. So I'll go 1 left, 2 up, 1 left, 2 up. Or I could have said twice of this is 2 left and 4 up. So 2 left and 4 up. Either way, I get there. So from this point it goes left 2. So I'm now going to go left 4 because I need to draw it twice as big. Then down 2 is now going to become down 4. Join them up. And we have it. Getting easier, right? Counting squares. This is a scale factor of a half, so basically half the size. And what also that means is half the journey from the centre. So let's go to here because it's the closest point. So it's 1, 2, 3, 4 squares across to the right, and then 2 squares up. But now we're only going to do half that journey. So that's going to be 2 to the right and only 1 up from the same point. So 2, 1. And you should be able to see that that is clearly halfway. Now, to go from here, it goes right 2, so now half of that is only going to be right 1. Then up 2 is now going to become up 1, and we have it. There we go. Alright. 2/3, a little bit harder, and this time, I like these, we've put the centre inside of the shape. So let's go to this point here. That's 3 right and 3 down. what is 2/3 of 3? Hopefully you understand that is 2. So now we're going 2 right and 2 down. 1/3 of 3 is 1, splitting 3 into thirds, 3 equal pieces. So it's 1. 2 of those would be 2. Right, so we're going 2 right and 2 down. Okay, it's in a nice straight line. Right, so how long is this shape? So it's 1, 2, 3, 4, 5, 6. Right, so this is a 6. 2/3 of 6 is 4. 1/3 being 2. So 1, 2, 3, 4. How many up is it? 2, 4, 6, 8, 9. So this is now going to be 6 when we find 2/3. And we can fill in the rest of the rectangle. And we can join it up. Oh, sorry, it's a bit of a dodgy one. Try that one again. Better. Okay, so even with 2/3 we can handle that because it's just counting squares. Now, I'm going to go back to the very first one, because the beauty of these is you don't have to have the answers. You know you're right, because watch this. Just see if we can. I'm going to just use a different line tool because that one's horrible. I'm going to go for pink. No, let's go for red. Pink. So if I join the top left and keep it going to the top left, so join the top left and top left of both shapes, it will go through the center of enlargement. If I do that with every single matching pair, so top right to top right, bottom right to bottom right, you'll see they all go through the center of enlargement. That's a wonderful way of checking your answer, because if it doesn't work, obviously your shape is wrong. And you may have just messed up the scale factor going up or down. Let's have a look at this one. So top left to top left. You don't have to do all of them. Bottom right to bottom right. You see, it all goes through. So that one's definitely correct. And sometimes I just do a couple like that, so I'm really happy that my answer is there. For this one, I do all three. So top left to top left. You can see it's spot on. Bottom right to bottom right. There we go, we know this is good. Okay, I'm really happy with that answer. And the last one we did was here. So bottom left to bottom left, keep it going. Bottom right to bottom right, keep it going. Okay, you can see that all of these points went through the center of enlargement. So if they ever ask you to describe an enlargement, what we need is a scale factor. Okay, so I'm going to write scale factor. I'm just going to write SF on this one. And we need a center of enlargement. And that is always written as a coordinate. Now, what I'm actually going to do is I'm going to just rub out this B here, because I'll keep it on the next one, but sometimes what we call it is A dash. Okay, A apostrophe, and that means we've got the object, the starting one, and then the image that it's producing, like the object being shined a light on it, and that's the shadow that it's making. So what we're going to do is we're going to go from A to A dash, and on this one we're just going to go A to B. Okay, just so you're familiar, if you see some questions with A dash and A, this is the start, this is the end. Right, so what is the scale factor? We can see that the sides have been multiplied by 2. Now to find the centre of enlargement, we're going to do exactly what I just did. So bottom left to bottom left, just draw a line. We're going to tops, and you can see they all meet at this point here. And where is that? That's minus 4, 2. So from minus 4, 2. Let's have a look at this one. So this is 1 along, this is now 3, so we can see a scale factor 3. Let's just check the vertical distance as well. We've got 2 and we've got 6, so that works. Now where's it from? So we get our line tool, top right to top right, bottom right to bottom right. You can do it as many times as you need to, but now I've got 3 lines all going to the same point, and that is 4 minus 1. Okay. That's it. Enlargement is just drawing things twice as big. When it's the point, you've just got to take into consideration that distance and draw it in exactly the right place. If you're unsure, we just want to check anyway. Draw the lines, they're called rays, because they have a start but no end. And they should all converge to one point, and then you know you're right. Okay, hopefully that's made perfect sense, and best of luck trying.